Hi there, folks. Today we're looking at absolute value equations. And to solve absolute value equations, first we need to talk about what the absolute value is. The absolute value is just a measurement, and it's measuring the distance away from zero. Okay? And so when you think about measuring things, almost like counting the distance, we always count in terms of positive. Like if I had a number of objects on a desk, you wouldn't start counting, -1, -2, -3. No, you would say 1, 2, 3, 4, regardless of the direction in which you were counting those things, okay? Or the order in which you were counting those things. And so that's kind of the idea behind absolute value, is we're simply counting how far away the thing is from zero. And when we count in terms of positive numbers. For example, if I look at something like this, and notice I have a number line here, the first one is the absolute value of -5. And so if I count from 0 and count how many spaces it is to get to -5, again, count it like you're just counting the number of objects or the number of spaces here. So it's 1, 2, 3, 4, 5 units away. And so I count the distance as a positive no matter which direction I'm counting in. Okay? So the absolute value -5, well, that's +5. Even though the value is -5, how far away it is from 0, the distance from 0 is still 5 units away, okay? It just happens to be 5 units to the left, okay? And that's how we denote negative numbers on a number line, is in terms of directions. But absolute value, we're just finding the distance, which we always measure distance as a positive. If I look at something like the next one, absolute value of 7, well, once again, I just count the distance. So from 0, let's count up to 7. That's 1, 2, 3, 4, 5, 6, 7 units away. All right? And so the absolute value of 7, well, is still 7. Okay? And so the idea here is the absolute value is always going to come out positive because we're always just counting the distance, and distance is always positive. And we're just simply saying, hey, how far away is -5 from 0? Well, it's 5 spaces away. How far away is 7 from 0? Well, it's 7 spaces away. And so the next question, how far away from 0 is 4? The absolute value of 4? Well, that would be 4 units away. So the absolute value of 4 is a 4. And then -6, the absolute value of -6, well, how many units away, how many spaces away from 0 is -6? If I counted the spaces, well, it would be 6 spaces away. So the absolute value of -6 is +6. So again, we're always measuring the distance, and distance is always measured as a positive number. All right? We put negatives on the number line, depending on which direction we go. But if we're counting the distance, we always count it as positive. Okay? And so when I think about that, and I start thinking about the values that are the same distance away, if I scroll back up to the number line here for a moment, but, like that first one, absolute value of x equals 5. So it's essentially saying which values are 5 units away. And so when you look back at the number line and say, okay, which values are the same distance away from 0? Like if I looked right here at 3, that's the same distance from 0 as -3, right? See, if I'm starting at this value, those are each the same distance away. Or if I looked at +10, well, that's the same distance away as -10. Okay? If I count 10 in each direction, counting one direction gives me a +10, counting the other direction, I end up at -10. And so the distance that I'm counting is the absolute value, but there's 2 different values that give me that same distance, okay? 3 is the same distance away as -3, all right? 10 is just as far away from 0 as -10, okay? And so when you look at absolute value equations, saying, hey, the absolute value is 5. So x, whatever x happens to be, is 5 units away, which means it could be one of 2 things. Which 2 values are 5 units away from 0? Well, it depends on which way on the number line I go. If I go in the positive direction, well, +5 is 5 units away. If I go in the negative direction, well, -5 is 5 units away. Both of these have an absolute value of 5, so both of these would be an answer to this particular equation. It's saying, hey, the distance is 5. Which two values could it be? X could be a -5 or X could be a +5. Likewise, if I look at this one, it says, hey, the distance, the absolute value is 8. So which two values have a distance of 8? Well, on the left side, -8 is 8 units away. And on the right side, +8 is 8 units away. So those are the two answers, okay? X could be a -8 or a +8. They're both 8 units from 0. They both have the same distance from 0. And then if I look at this one, it says the absolute value is a -3. Well, this is kind of strange because the absolute value is the distance, and I always measure the distance as positive. Well, here it's saying when is the distance, the absolute value, when is the distance negative? Well, we never measure distance that way. If we see this scenario, we say no solution, okay? I measure distance as positive, so therefore the absolute value can't equal a negative, okay? And so the kind of the theme that happens here is when you solve absolute value equations, there's really two options to get that distance. So when we do this, we have to set up two equations. You know, in these previous examples, absolute value of x equals 5, it was x equals 5 and x equals -5. It was x equals 8 and x equals -8 for the absolute value of x equals 8. And so the idea here is if I have the absolute value equals something, well, the thing in the absolute value could be the positive version or the negative version of that thing. And so when we look at a more complicated example, something like this, it says the absolute value is 10, right? Which means the distance could be a 10, but it could also be a -10, all right? And the thing that's inside my absolute value is the x plus 4. And so the idea here is we're saying, hey, that x plus 4 either has to be a 10 or it has to be a -10. It has to be one of those things because those are the two things that are 10 units away. And now I just have two equations to solve. Look at that first equation, x plus 4 equals 10. I subtract 4 from each side. So x equals a 6. That's one of the values that could work. And then here I subtract the 4 from each side. And I get x equals a -14. That's the other value that can work. And both of these are good answers. You could plug them back in, and you'll get the same thing. If I do 6 plus 4, that's 10. Well, yeah, that's 10 units away, so the absolute value of 10 is 10. If I plug the -14 in, -14 plus 4, well, that's -10. Well, isn't that 10 units away? Yeah, absolute value of -10 is a 10. So it's giving me the two values that give me that distance, okay? If I look at the next one, same kind of thing. I'm going to set it up as two equations. I'm going to say, hey, well, the 2c minus 2 could equal a 6, or the 2c minus 2 could equal a -6. Because, again, I'm just listing the two values that are 6 units away. See, the absolute value is 6, so the distance is 6. Well, that could be a +6 or a -6. Those both signify that same distance, okay? And so now I just solve each of these equations. Ready? This one, I add the 2 to each side. And then divide by the 2. So I end up with c equals 4. The next one, once again, I solve this equation. I'm going to add 2 to each side. Remember, to undo subtraction, I use addition. To undo multiplication, I use division, so divide by 2. So I get c equals a -2. That's it. These two c values will give me the two distances that I was looking for. One of them gives me a +6, one of them gives me a -6. Well, those are both the same distance away. If I look at this guy, once again, the absolute value equals to 5.5, and even though it's written on opposite sides this time, it's still the absolute value equals this thing, which means the thing inside the absolute value, the t plus 2, that could equal 5.5, or the t plus 2 could equal -5.5. I split it up into two equations, okay? The absolute value can equal to the distance of 5.5 could be two different things. It could be +5.5 or -5.5. And now I solve each. This one I'm going to subtract the 2. t equals a negative 7.5. And that's it. Those are the two values that work, okay? So again, whatever's inside the absolute value, we just split this up and say, hey, it could equal the positive version or the negative version. Those are both the same distance away. And then we get something like this. Absolute value of x plus 5 equals a negative 4. We should stop. We should pause right away and look at this. It says the absolute value equals a negative 4. It's saying the distance equals a negative 4. When will the distance be a negative? Well, never. Absolute value always has to equal a positive. And so always check the equation first. If you see the absolute value equals a negative, well, that's impossible. The absolute value always equals a positive. So we can say no solution for this one. Okay? And if we had split this up and solved, we get two answers that don't actually work. Okay? So always check the equation first. Absolute value equals a positive because we're measuring the distance. Okay? If we have the absolute value equals a negative, that's impossible. All right? So it's no solution. When we're solving these equations, because there are two values that can be that same distance away, we always split it into two. And the way to do that is we take what's inside the value, absolute value equals the thing on the other side of the equal sign, or it equals the opposite. So like here, x plus 4 equals the 10, or x plus 4 equals the negative 10. C minus 2 equals the 6, or 2c minus 2 equals the negative 6. Here, the thing inside the absolute value, t plus 2 equals the 5.5, or t plus 2 equals the negative 5.5. That's how we solve absolute value equations, okay? We always split it into two and solve each.